Good morning, good evening, good afternoon, ladies and gentlemen. Yes, I realized I said good evening before good afternoon. Oh my god. I hope you all had a wonderful day and welcome to our distribution video. Now, in distribution, we are often learning this tactic, which is you have a number or a variable or anything outside of your bracket and you're going to want to multiply on the inside. Now, the popular example among my students seems to be these days the Pokemon Go example. Yes, I'm using Pokemon Go example. If you hate Pokemon Go, you might probably leave now because the jokes are going to be that sarcastic. So, let's look at an example. Now, in this example, once again, we're talking about distribution. So, in distribution, they'd often ask you questions where they would tell you to simplify or expand and then simplify. But either way, your end goal is to simplify. Now, in this first example here, you have a 3 on the outside and you have a 4x plus 2 on the inside of the bracket. Now, from before, we learned something called bedmass, and bedmass would tell us we'd have to work with our brackets first, then our exponents, then our division, math, well, not math, multiplication, addition, and subtraction. Now, inside our brackets, we have 4x plus 2. Now, 4x is not the same thing as a 2. It's like you're saying you have apples, you have 4 apples, and 2 bananas. So you can't necessarily say 4x plus 2 is equal to 6x. This is absolutely and utterly wrong. Because that is like you're telling me that 4 apples plus 2 bananas is 6 apples. That's obviously not true, and that's also obviously not the right spelling. Yeah, I guess you guys can see why I'm a math teacher. Huzzah. All right, so now that you know that, so this is what we call like terms. The x is not the like term with the 2. Why is that? Because x is a letter and 2 is a number. So if I had 2 plus 2, these are both what we call like terms. Why? Because they are both numbers, no other letters. So I can add them together normally and say 4. But if I have x plus 2, this x is not the same as the 2. Once again, it's like I have 1 apple plus 2 bananas. So x plus 2 is just x plus 2. It's a trick question. So when we try to do bedmass here, obviously, we can't do anything with the 4x plus 2. So you don't have to do the bracket step. Obviously, there's no exponents here, there's no division, but there is multiplication. There is a 3 on the outside, and as you notice, between the bracket, there is absolutely no addition or subtraction or any kind of sign. So you assume this is multiplication. Okay? And now to the popular Pokemon Go example. I apologize for the cringes. So, what you want to do, assume 3 is the trainer, and he wants to catch them all. So, 3 has to catch this 4x. Let's call this 4x Pikachu. All right, you want to catch 4 Pikachus, and you want to also catch this 2 here. Let's call him Bulba. So we want to catch Pikachu, and we want to catch Bulbasaur. And by catch, I mean multiply. Now, when we're multiplying, when you have 3 times 4x, I'm going to put this in the corner here, 3 times 4x. The 3 obviously doesn't multiply with the x because, well, the x is a variable. I don't know what it is. So you'd multiply by the number beside the x, which we call the coefficient. Okay, so you would do 3 times 4, which would be 12x. So, in this sense, 3 times 4x is 12x. Okay, so we've cut that Pikachu. Pika. Plus, well, you always want to make sure you're taking that sign that's beside the 2. The sign is very important. So now you have plus 2 times 3. So 3 times 2, that is 6. We have now caught that Bulbasaur. Have we caught both of our Pokemon? Absolutely. We have done distributing. And that is the distribution rule. Now, let's look at a little bit of a more difficult question in this next part here. Now, in this second example, the only thing I've changed here is that I've added an x to my my 3. And I put a negative beside the 3. So once again, you're still going to be trying to catch them all. But now, it's not just the 3 that's trying to catch them all. It's the negative 3x needs to catch them all. Why? Because they are attached to each other. Again, because they're multiplying each other. So now you want to catch them all. You're going to need to do negative 3x times x and negative 3x times negative 3. And this is often where a lot of students would make their mistakes. They would forget about this negative. And the thing you have to realize is that negative follows the 3 everywhere. So it is not a positive 3 you're multiplying. It is a negative 3. Okay? So you have negative 3x times x. Well, again, nothing happens with the negative 3. Why? Because there's no other number in that first term. But there is an x. So the x will multiply with the x. And x times x is x squared. Now, you then have minus 3x times minus 3. So you have minus 3 times minus 3 because nothing happens with the x. I'm going to put that x in a nice blue color here. Yep. So I have minus 3 multiplied by minus 3. What happens when you have a minus multiplied by a minus? That's like having 2 bad apples gives you a good apple. So that will make it a plus. And then you have the 3 times 3, which is 9. And that's the final answer. We have negative 3x squared plus 9x. Have I caught all my Pokemon? Absolutely. And that will be the last Pokemon joke and the last example of this video. I hope you have enjoyed this video and learned something about distribution. Again, I am very sorry, very, very sorry for my horrible jokes. Take care.